All right. So let's take a look at some exothermic reaction. That means reactions which are releasing heat. So guys, can I say if you're heating water at your home and you have natural gas structure is CH4. The reaction, the heat is result of combustion. That means natural gas is burned. It produces carbon dioxide. Its carbon is converted, oxidized to carbon dioxide. Its hydrogen is oxidized to water. And obviously, burning methane gas is going to produce heat. And suppose we have measured it, and you're going to do experiments like that in Chem 1A. You can measure heat exchange in a chemical reaction. And obviously, burning gas produces heat, and I write amount of the heat produced. For 1 mole of methane, this is measured, 213 kilocalorie of energy is released per mole of methane in this reaction. Can I say because I wrote heat on the product side, heat is generated, heat is released. In other words, this reaction is exothermic, is producing heat, obviously. And we said there are 2 methods of showing exothermic reaction. One is to say that delta H is negative 213 kilocalorie per mole. That means 213 kilocalorie of energy is released to the surrounding. Negative is loss of heat, loss of energy, so released. So this is one way of showing that this reaction is exothermic. Why? Delta H is negative. Heat is released to surrounding. Another way of showing the same fact, same experimental measurement is on the top, we say heat is produced. Why? Because we know water is produced, we know carbon dioxide is produced, heat is on the same side, heat is produced, is a product. So 2 ways of showing the same concept. An exothermic reaction, its delta H must be negative, or the amount of the heat released shows up as part of the chemical equation. And it must be on the product side. Heat is on the product side, heat is produced. Any question, guys? Any questions? And if I go to next slide, if you want to make nitrogen monoxide, it is produced from nitrogen gas reacting with oxygen. The reaction needs heat. Heat is needed. Then you get 2 moles of nitrogen monoxide. Do you see, did we say left-hand side of every chemical equation are reactants? And did we say right-hand side are product? So what's the meaning of reactant? Those are things which are consumed, right? At the end of a chemical reaction, reactant are consumed to produce product, right? So Can I say heat is consumed, reaction needs heat? So this reaction is endothermic. Endothermic. The heat is on the reactant side. Energy is on the reactant side, not on the product side. Another way to show the heat exchange in this reaction is that the change of heat, exchange of heat, heat of reaction, enthalpy is positive. Did we say positive is gain? The system is gaining heat. It needs heat. So endothermic. Do that make sense? Any questions? So I'm going to go to the next slide. Guys, go ahead, answer this. See if we can figure this out. Abigail, good job, Abigail. You were the first one. Good job. Good job. I got 4 people, 3 people, 4 people, yes. 4 people out of 7. So that's majority of my class. Yeah, oh my God, 7 people, oh my God. You all got it, huh? Oh, I have 8 participants. 7 out of 8 got it. Where is my number 8? Where is my number 8? Who is my number 8? Who is? Okay, so guys, does this make sense? Yes, my number 8 answered it too. Why? Look, energy is gained. Energy is part of the reactant. Reactants are consumed. Reaction needs heat. So if system is gaining heat, its energy is increasing, gain is positive. So positive delta H, and reaction is endothermic, it needs energy. All right, so why some reactions are exothermic and some are endothermic? So guys, I give you an analogy for bond formation. I said, think of bond formation between atoms like bond of marriage between atoms. Or bond between 2 people. And we said chemical reactions are nothing but breaking a bond and making a new bond. What happens if you are in a marriage that you are not happy? You try to fix it. If you can't fix it, you break the bond, divorce, and you make a new bond, marriage. Atoms do that too. So guys, is it fair to say, did we say that bond making between atoms releases energy? The opposite is bond breaking. Bond breaking needs a lot of energy. In other words, guys, if you want to separate from your spouse, you have to go through divorce and hiring a lawyer. It costs a lot. But if you're marrying, people give you a lot of presents and they send you to honeymoons and all that. So It's not going to cost a whole lot as much as divorce. So the same in chemical bonding. Breaking a bond takes energy, and making a bond releases energy. Take a look at this example. This is methane, natural gas. If you react it with chlorine in presence of light, and that's the catalyst. You make chloromethane and hydrochloric acid. There is a Cl here which is being hidden by my surface probe. So this is Cl. So look at the left, compare it to the right. Do you see that this bond is not here? So can I say one of the bond which is broken for this reaction to go, there should be bond breakage between carbon and hydrogen that consumes energy. Do you also see the bond between chlorine and chlorine is not on the right-hand side? The two chlorines are not together. So can I say this bond must be broken as well? So two bonds are breaking. One is CH bond, the other bond broken is Cl and Cl. Those are energy consuming factors. Those are divorces. Those need hiring lawyers. Those are expense. And guys, if you look at the right of this chemical reaction, do you see there is a new bond formed between carbon and chlorine which did not exist before? Bond formation. Do you see another bond which is formed? Can I say the bond between the blue hydrogen, this bond, is also bond formation? So bond breakage is consuming energy. Bond formation is producing energy. Just all you have to do, look at what is left over. Suppose you go to work one day, you work 8 hours, and you make $20 per hour, so $160 is what you made today. At the same time, you go for a lunch, and you have a lunch for $20. Is it fair to say that the take-home amount is what you made minus what you spent? In a chemical reaction, it's the same. Delta H, energy released or absorbed, depends on adding these two together, adding them algebraically. Bond broken needs energy, so positive energy. Bond formed, there is a negative energy. That means energy released. Add these together, you have the balance. Then you can measure delta H of a chemical reaction. I'm going to actually do this calculation for you.